Want to grow your own special mushrooms but don't have a pressure cooker and don't want to spend over €100? Then this is the perfect beginner's guide and the only tutorial you'll ever need. I'll show you step by step how to grow mushrooms from start to finish. Just follow along and you can harvest up to 100 grams, that's about 3.5 ounces, in no time. Everything starts with spores. You can imagine spores as extremely small seeds of your mushrooms. Under the right conditions, with access to nutrients, they'll begin to germinate and form a network of white strings called mycelium. In simple terms, you can think of mycelium as the roots of the mushroom. Once you've gathered enough mycelium, simply mix it with a suitable substrate, and a few days later, you'll see mushrooms grow. These will drop spores again, and the cycle begins all over. That's basically the whole process. Growing mushrooms isn't rocket science. One of the biggest challenges is contamination, such as mold or bacteria. These will compete with the mycelium and can overtake, outgrow, and eventually kill it. Contamination is practically everywhere. That's why it's crucial to prevent and eliminate it by sanitizing equipment, sterilizing grain, and practicing proper sterile techniques, each of which is covered in detail. Just remember, working carefully and thoroughly is the key to success. Here are all the items you'll need to grow your own mushrooms. Most of them are self-explanatory, but the ones that aren't will be explained in this video. Everything you need is included in the starter kit for less than €100. It takes you step by step through the entire process, from spore to mushroom, all the way to harvest and drying. If you're interested, you'll find the complete kit or individual items from it linked below in the description. You'll also find an FAQ, my blog, and more. Check it out to get everything you need to start growing today. In addition, you'll need a few basic household items. Some are optional, not essential, but definitely helpful. At the beginning of each chapter, you will find all the required materials listed. And if you prefer American measurements, turn on the subtitles. Begin by covering the holes of your mason jars with micropore tape. It allows air exchange for the mycelium to breathe while keeping contamination outside. Next, we have to prepare our agar by first pouring 50 milliliters of water into a small pot. After that, we add 1 agar malt mixture and stir everything around for 3 minutes. Don't worry if not everything dissolves. Once it's mixed thoroughly, bring it to a boil until these bubbles form. The bubbles indicate that the agar got activated and can now turn hard. Then, turn off the heat and mix it one last time. Now, you can evenly distribute the agar into the jars. Don't worry if you have some left over. After that, allow them to cool open for 5 minutes like this, which allows any excess water to evaporate. 1 agar malt mixture can be used for up to 4 jars. After the 5 minutes have passed, seal them loosely. I like to screw them fully on and then unscrew them slightly back as shown here. This helps to regulate the pressure inside the jars. Then cover the lids in aluminum foil, as this helps to avoid unnecessary moisture from getting inside the jars. Now, we have to sterilize our agar. For that, we are going to use a steam bath. You need something like a trivet, a grate, jar lid, or an old baking pan to place your jars on. Then, add at least 1 liter of water to the pot. Just make sure the water isn't touching the jars. Then cover it and bring it to a boil. Once it boils, reduce the heat to medium heat and sterilize your agar for 1 hour. After that, take the pot off the heat and let it cool down for at least 2 hours. Then take out the jars, tighten the lid, and take off the aluminum foil. If you want to ensure they are sterile, let them sit at room temperature for a few days. If nothing changes, they're sterile. This step is optional. You can also use a pressure cooker or an Instapot, which is even better for sterilization, either at 15 psi for 30 minutes or 12 psi for 45 minutes. Now we are ready to inoculate. This simply means putting the spores onto the agar. Start by disinfecting your gloves. Remember, gloves and a mask always go together. Next, spray a paper towel with disinfectant and wipe down the gray injection ports. Always use 70% isopropyl alcohol. 90% evaporates too quickly, and 50% isn't strong enough for proper disinfection. Then, open the sealed, sterile needle, remove the cap from the syringe, and screw the needle onto it. Quickly insert the needle into the middle of the gray injection port of your first jar and inject between 0.5 and 1 milliliter. Before moving on to the next jar, sterilize the needle again to avoid cross-contamination. Use your lighter to flame sterilize the needle for 10 to 15 seconds until it glows red. Then wait about 15 seconds for it to cool down before inoculating the next jar. After that, store your syringe in a dark, cool space for the next time. What I like to do afterwards is gently swirl the jars to help distribute the spores across the agar for faster growth. Once you've finished inoculation, store the jars in a dark location at temperatures between 21 to 27 degrees Celsius. This is what your agar should look like after 1 week. The spores will have germinated, and you should be able to see the first traces of mycelium. After about 2 weeks, the mycelium should continue spreading across the agar. And this is what it should look like a few days later. Once the entire agar surface is covered with mycelium, you can move on to the next step. Keep in mind, the duration can vary depending on genetics and temperature. Now is also a great time to introduce our free communities. We've just launched a new Facebook group, and we also run a Discord server with over 1,000 members. In both, you can join giveaways, ask questions to experienced growers, and share your progress. Links are in the video description. For the Discord server, simply accept the rules by clicking the green checkmark to start participating. First, we need to bring 800 milliliters of water to a boil. Then, cover the holes of your mason jars with micropore tape. Again, this will allow the mycelium to breathe later on. As the water begins to boil, reduce the heat to medium and add the rice. Set a timer for 10 minutes and stir occasionally. After 10 minutes, drain the rice. It works best with a colander, but it also works without one. Now, the rice has the perfect texture, slightly cooked but still firm. Rinse it with cold water to stop it from cooking further. Now, shake it a few times to remove excess moisture and let the rice sit for about 30 minutes to cool down. Once the rice has cooled, evenly distribute it into your jars. The jars won't be completely full because we need to leave space for a method called break and shake, which I'll explain later. This is what it should look like afterward. Before moving on to sterilization, screw the lids on loosely and cover them with aluminum foil. As you can see here, the lids should be tight, but still loose enough to move slightly. Now we sterilize the grain the same way we did with the agar. Take a large pot and add at least 2 liters of water. Again, make sure you have something to keep the jars raised so the water doesn't touch them. We don't want the rice to continue cooking as it can burst open. This time, I used an old baking pan. If you don't have a pot this size, you can also use a smaller one and place the jars on their sides. After that, place the jars in the pot, put on the lid, and bring the water to a boil. Once it boils, reduce the heat to medium and sterilize the grain for 2 hours. Always keep an eye on it as you may need to add more water. This method works very well, but using a pressure cooker is slightly more effective. If you plan to grow mushrooms more often, you should consider getting one. You can often find them very cheaply secondhand, for example, on Facebook Marketplace. Sterilize either for 1.5 hours at 15 psi or for 2 hours at 12 psi. After 2 hours, take the pot off the heat and let it cool for at least 6 hours. Then remove the jars, tighten the lids, and take off the aluminum foil. One steaming session might be enough, but to further reduce the risk of contamination, you can repeat the steaming for a second or even third session. As the name suggests, we transfer the colonized agar to a grain, such as brown rice, where the mycelium receives fresh nutrients to continue growing. This step is very vulnerable to contamination, which is why we must work carefully and thoroughly. First, put on gloves and a mask and start disinfecting your workspace. After that, take your monotub and disinfect it as well. Make sure to close all windows and turn off any fans or air conditioners to minimize air circulation. Air movement can stir up contamination and negatively affect the transfer process. Then take your monotub, flip it upside down, and set it aside. If you're using a kitchen rack, disinfect it as well. Keep in mind that it's optional. I'll explain later why it's not a must-have, but a nice-to-have. Next, place your kitchen rack inside the monotub. Now we need to disinfect our mason jars from top to bottom. Keep in mind that working clean and sterile is the most important part of mushroom cultivation, so don't cut corners. Once you've finished, place them inside the monotub as shown in the video. It makes working inside the box much easier. Next, we need to seal the holes with tape. Regular duct tape works fine. The most important thing is that no air can pass through, so we end up with a fully closed monotub that will function as a still air box. And then we have to wait for at least 20 minutes. And this is how a still air box works. As mentioned before, millions of contaminants like dust, bacteria, and mold spores float around in the air. We want to avoid them because they compete with our mycelium. As just shown, we need to seal the holes of the still air box with tape. This creates two separate air systems, one outside and one inside the box. Now that the box is completely closed, all particles inside are slowly pulled toward the bottom by gravity, and no air movement can stir them up. That's why we have to wait 20 minutes for all particles to settle down. Because once all particles have settled down, we have this area of clean, still air inside the box. Then, carefully remove the tape on both sides. Now you're ready to use the still air box. I like using a kitchen rack because it elevates the work area and keeps your jars from coming into contact with any particles on the bottom. And here, you can once again see why a still air box can drastically improve your success rates. After the 20 minutes have passed, slowly remove the tape on both sides. Go slowly to avoid creating air movements that could stir up particles from the bottom again. Then, disinfect your gloves again, reach into the still air box, and loosen the lids of the first two jars, but don't remove them yet. Before we continue, flame sterilize your scalpel for 15 seconds, just like we did with the needle in Chapter 2. Never do this inside the still air box, as the disinfectant you used earlier could catch fire. Next, take the agar jar, remove the lid, and cut the agar into small pieces. They don't have to be perfect. Then, remove the lid from your rice jar. Use your scalpel to transfer the agar pieces into the rice and quickly close the lid again. That's it for the first two jars. Then, reposition the jars as shown in the video. Sterilize the scalpel again and repeat the process with the remaining jars. If anything spills, don't put it back into the jar. Also, avoid touching the inside of the jar as this increases the risk of contamination. Work quickly but also calmly to prevent any air movement. Once you're done, shake the jars well so the agar pieces are evenly distributed throughout the entire jar. If you have any questions so far, feel free to ask them in the comments. Store in a dark place at an optimal temperature between 21 to 27 degrees Celsius. If it's cooler, the process won't stop. It will just slow down. Now you can see how the mycelium slowly transfers from the agar to the rice. When the rice is 30 to 40% colonized, it's time to break and shake. We shake the jars to break up the mycelium inside. Shake them until most of the large clumps are dissolved. This step is very important because it breaks up the mycelium, creating more inoculation points, which leads to quicker growth. After shaking, there should hardly be any white spots left visible. Return the jars to their previous location. Now you can see how the mycelium grows from everywhere. This is also a perfect example of different genetics. The mycelium on the left side is denser and colonizes faster, while the mycelium on the right side grows more slowly and is less dense, which is why it looks more grayish. But both are healthy. Here is a time-lapse of the back side of the jars, where you can see again that the mycelium on the left grows much faster than the one to the right. Once every grain is colonized and there are no signs of contamination, the mycelium is ready for the monotub. If you've made it this far, you most likely be successful, as this was the most difficult step. Eventually, you'll have to deal with contamination. That's normal. Here is what it could look like. The jar on the right has some kind of wet, rotten cobweb mold, and the jar on the left has green mold, also known as trichoderma. Another way to detect contamination is by smell. For example, sweet or sour smells. Once you've spotted contamination, toss it out immediately. Be sure to do this outside so mold spores don't affect future growth. First, unpack the cocoa coir, the substrate, and put it in a clean pot or bucket with a capacity of at least 5 liters. We need 1 to 5 cocoa to water ratio for the perfect field capacity. Field capacity basically means the ideal moisture level in the substrate for your mushrooms. With perfect field capacity, you won't need any further watering. For 300 grams of cocoa coir, we'll need 1.5 liters of water. Bring the water to a boil and add it to the cocoa coir. This process is called pasteurization. The cocoa coir doesn't need to be sterilized because it's naturally resistant to mold. Some people like to add gypsum or vermiculite, but I don't find it necessary. Put the lid on and let it sit for at least 6 hours to cool down. In the meantime, we can prepare the liner. We need it to prevent side pins. More on side pins later. First, separate 8 strips of duct tape. Then, take your foil, lay it in your box, and fold the corners into the center. Make sure all edges have about the same height. Next, tape the corners together as shown in the video. This is only one of the many ways to build your liner, so you can do it however you prefer. Now tape the corners to the sides. This method helps stabilize it and makes it easier to remove the liner from the monotub for the harvest. The next step is to seal the large holes with tape to keep in humidity. Regular duct tape works just fine. Just make sure the tape doesn't come off during the process. Now back to the cocoa coir. Once it has cooled, mix it well by hand. Don't forget to use gloves and a mask. If you want to check whether your cocoa coir has the perfect field capacity, simply take a handful and squeeze it as hard as you can. If only a few drops of water come out, you nailed it. The last preparation step is to disinfect the liner and your spoon. Before scraping the rice into the liner, smell it first. It should smell fresh and earthy, just like mushrooms. Definitely not sweet or sour. A strange smell is a strong indicator of contamination. If everything is fine, you can continue. Once all the rice is in the monotub, break it up with your hands until there are little to no clumps left. Then, take half of your cocoa coir and add it to the monotub. Mix everything thoroughly from top to bottom until it's evenly distributed. Don't forget the corners. It's better to mix too much than too little. This is important for creating a dense pin set, which leads to more mushrooms. Once everything is well mixed, lightly compress the surface to even it out. Compressed edges are especially important to prevent side pins. Then, add another 3 to 4 handfuls of cocoa coir as a casing layer. Again, spread it evenly and lightly compress it. A casing layer helps keep the humidity inside the substrate. You shouldn't be able to see any rice anymore. You'll probably have some cocoa coir left over, which is fine. Finally, close the lid and you're done. Now, place your monotub somewhere with temperatures between 21 to 27 degrees Celsius. The lighting conditions aren't very important. Just avoid direct sunlight. Only open the lid during harvest. Otherwise, it's unnecessary. I know it's tempting to check inside, but that only increases the risk of contamination. There's also no need for fanning or misting if the substrate has perfect field capacity. When your substrate is mostly colonized, and more importantly, when the first pins appear, it's time to introduce fruiting conditions which will lead to the fruiting stage. This is how the colonization works. All the rice grains are evenly spread throughout the cocoa coir. What happens next is that the mycelium from each grain begins to colonize the cocoa coir. Over time, the mycelium reaches the surface of the substrate, as you can see from the top view. Slowly, the mycelium spreads throughout the entire cocoa coir until almost the whole surface is covered. Then, eventually, you'll start to see the first pins, small early-stage mushrooms. Once most of the surface is covered up and first pins appear, you can move on to introducing the fruiting stage. In order to start the fruiting stage, we need to introduce fruiting conditions. This is done by increasing the fresh air exchange. All we have to do is remove the plugs from the monotub and cover the holes with micropore tape, which allows fresh air to enter while keeping contaminants out. The larger holes should remain sealed. Instead of micropore tape, you can also use polyfill or filter patches. During the colonization of the cocoa coir, the mycelium produces a lot of carbon dioxide, also known as CO2. For mushrooms to grow, however, they need oxygen. That's why we replace the plugs with micropore tape. This allows airflow, known as fresh air exchange. The airflow removes the CO2 and brings in fresh oxygen for the mushrooms to grow. It's similar to opening a window, except the micropore tape keeps contamination out. You don't need to understand this in order to grow mushrooms. It's just for those who are curious about how it works. Simply place your monotub back where it was before, and your mushrooms will flourish in no time. The optimal temperature range for fruiting lies between 22 to 26 degrees Celsius. They usually take about 5 to 9 days to grow. You should begin harvesting once the caps start to open and the veils begin to break. I'll show you later exactly what that looks like. To harvest your mushrooms, disinfect your gloves, put on your mask, and remove the liner from the monotub. There are two main harvesting methods, the twist and pull method or the scalpel method. For the twist and pull method, firmly grab the mushroom near its base, then gently twist while pulling upward. I prefer this method because it's the quickest. You can either harvest all of the mushrooms at once, or pick only the mature ones and let the smaller mushrooms grow for another 12 to 24 hours before harvesting the rest. If you choose to let the smaller mushrooms grow a bit longer, simply put the liner back into the monotub, close it, and place it back where it was. This white grayish tissue here is the veil. Once your mushrooms open their caps and the veil starts to break, it's time to harvest. Here, you can see what it looks like when the veil breaks. Thanks to Smegar05 from Reddit for allowing me to use this. Definitely check him out. Once the veil has broken, it's best to harvest within 12 hours to avoid spore drop. This is important because spores signal the mycelium to stop producing new mushrooms, which means you might not get any further flushes. Here, you can see all three stages with real mushrooms. After 24 hours, most of the smaller mushrooms should be mature so you can harvest the rest. For harvesting with a scalpel, simply cut the mushroom at its base. For side pins, I recommend using the scalpel. Side pins grow along the edge of the substrate, which makes them more difficult to reach. Unfortunately, I didn't get any side pins to show, but that just means the liner worked perfectly. Fresh mushrooms stay good for only a few days, which is why I like to dry them within 48 hours of harvesting. And here is what I got from the second harvest. Before drying the mushrooms, we'll take a spore print to collect new spores so we can grow new mushrooms. Start by disinfecting a sheet of aluminum foil and a bowl. Next, cut off the cap of a mushroom and place it gills down on the foil. Cover it with the bowl and let it sit for 24 hours so the spores can drop. After 24 hours, carefully remove the cap with a scalpel and leave the spores for another 24 hours to dry. You can still dry and eat the cap afterward. Once the print is dry, fold the foil as shown. Now, it's ready for use. Store in a dark, dry, and cool place. Spore prints can remain viable for several years. I recommend making several prints at once to increase the chances of getting a clean one. Before you start, remove the remaining substrate from the mushrooms with your scalpel. For drying, options like the oven or an air fryer can be used. However, there is a high risk of burning your mushrooms. That's why I would avoid it at all costs. I will show you how to dry your mushrooms with a dehydrator and how to dry them with the drying packs that come with the starter kit. If your mushrooms turn partially blue after the harvest, don't worry, that's just bruising. For the dehydrator, make sure to evenly distribute them without being stacked on top of each other. To speed up the process, I recommend splitting larger mushrooms and cutting off the caps to fit them into the dehydrator. Dry them at the lowest possible temperature. For me, 35 degrees Celsius for 8 to 12 hours until they are cracker dry. I'll show you later how you know they are properly dry. If they are not cracker dry after 12 hours, continue until they are. Since not everyone has a dehydrator, I recommend using the drying packs, especially for smaller amounts. It's a cheaper and more effective method. You can also get them separately from the kit. Before we start, I like pre-drying mushrooms with a fan. For that, evenly spread your mushrooms on a piece of cardboard or some parchment paper on a baking tray. Pre-drying is not necessary, but significantly shortens the drying time. Then, put a regular fan, no heater, next to it. Turn it on and leave it for 12 hours. After that, they have lost most of their moisture, but still bend and are not cracker dry. Next, take your drying packs and put them in an airtight container. Then, add a layer of paper towel and put your mushrooms on top, making sure they don't touch each other to avoid spots where humidity can accumulate. The packs will absorb the remaining moisture from the mushrooms. Close the lid, put it in a dark, cool spot, and wait for 24 hours. After 24 hours, take out your desiccant packs, put them on a baking tray with parchment paper, and prepare the oven at 90 degrees Celsius for 90 minutes fan mode. This allows you to regenerate the desiccant packs and reuse them. Meanwhile, keep the mushrooms inside the airtight container so they don't pick up moisture from the environment. You can also reactivate them in the microwave, just 3 times for 5 minutes at 500 watts. After that, take them out, let them cool down for 5 minutes, and put them back in the container with the mushrooms. Repeat this process until your mushrooms are cracker dry. This is what cracker dry looks like. They break without any resistance or bending. And now, they are ready for long-term storage. Here, you can see everything we got from the first flush. So, how much did we get? In the first jar, we're going to weigh what we got out of the dehydrator. Always use airtight glass jars, as plastic containers tend to get porous and leak air and moisture. Usually, you can expect anything between 20 to 50 grams dried for the first flush. This results in almost 21 grams of dried mushrooms. Adding 10 to 15 drying packs helps prevent mold and moisture, as they are also perfect for preserving mushrooms. In the second jar, we're going to weigh what we got with the drying packs. This results in almost 8 grams. With both combined, we harvested around 29 grams. With several flushes, you can easily get to 100 grams. Last but not least, store your jars in a cool, dark spot to ensure a long shelf life. Directly after the harvest, we prepare everything for the second flush. For that, pour 1.5 liters of cold water straight onto the substrate into the liner. Tap water is fine. The cold water prevents bacterial blooming during rehydration. If your substrate starts floating on the water, don't worry. That's no problem. The substrate will still absorb the water. Close the lid and let it soak for around 12 hours. After 12 hours, remove any excess water. Hold the substrate firmly so it doesn't fall out. Once the water has been removed, put the lid back on and place your monotub where it was before. Now we can wait for the second flush. Here is my second flush. Repeat this process after each harvest. Usually you get 3 to 4 flushes, but you can get up to 7. First, we need to prepare new agar and flame sterilize the scalpel. Then loosen the lid. It's basically the same as the spore syringe, as we put spores to agar. I recommend using your steel airbox for higher success rates. Next, unfold your spore print and carefully scrape off a few spores. Be careful not to damage the aluminum foil. You need about a knife tip's worth of spores. That is more than enough. Put it onto the agar, close the jar, and you're done. Lastly, seal the spore print again. I prefer inoculating several agar jars at once, just in case one gets contaminated. If you harvested very large mushrooms, it might be worth cloning them to keep the genetics for future cultivations. It's not very complicated and is similar to the step before. Instead of the spore print, you take a large mushroom, split it in the middle, and cut out a small piece of the inner tissue. We take a piece from the inside because it is most likely to be sterile. Don't forget to sterilize your scalpel. Then, put the tissue onto the agar and you're done. The mycelium will grow just as it does with the spores. After that, you can simply dry the remaining mushrooms. And that's it. It's all about working sterile and being patient. It's no rocket science. Now you have all the information to grow your own mushrooms. If you enjoyed the video and want to see more DIY content, feel free to leave a like and subscribe. Thanks for watching, and best of luck.